Welcome to the channel. I'm explaining Kirchhoff's voltage and current laws in this session. So while doing analysis of circuit, these two laws are very important, KCL and KVL. So first, I consider KVL, Kirchhoff's voltage law. So this law is nothing but simply the summation of voltage in the loop that is equal to 0. So we will understand this by simple circuit. This is resistance. This is one more resistance. This is voltage, positive, negative, V. This is complete circuit. This is R1. This is R2. The current flowing through this is I1. So this is positive. This is negative. So in this case, what is given? This is the voltage source which has positive terminal, negative terminal. Current will flow from positive terminal to the negative terminal. I have considered the conventional current direction. Resistance R1, resistance R2. So what we have to do in this case, first we have to consider the complete loop while calculating the summation of voltage. Second thing, consider the positive terminal and negative terminal of the battery. Accordingly, decide the direction of conventional current from positive to the negative and give the current name I. Now we have to move in the loop in a clockwise direction, in the current direction, I mean to say. So while moving, we have to assign the signs. So this is from positive, negative. This is positive and negative. So what I did, I moved in a clockwise direction. While moving, I assigned the conventional. While moving, what I assigned the sign. This is positive, negative. This is positive, negative. And accordingly, we have to calculate. So while calculating, we have to consider these signs. So V is the voltage according to the Ohm's law. V is equal to IR. So instead of voltage, we can consider IR also, because in the loop we have given R1 and R2. So V is equal to IR. So accordingly, V, now what we have to do in this case, this is positive and negative. This is positive, negative, this is positive, negative. We assign the sign and we have to move in a clockwise direction. So we have to consider the second sign, ended sign. So we have to consider the voltage source sign in the end while moving in a clockwise direction. So while moving in a clockwise direction, in the end, what I am getting at voltage source positive. So this is positive V. Move ahead towards the resistance while moving in the clockwise direction. In the end, at resistance 1, what sign I am getting? Negative. So this is minus IR1. So in terms of IR, we have to write the voltage at R1. Accordingly, what we are getting? V minus IR1. The same way, moving towards in a clockwise direction, the second sign at the end, I mean to say at the resistance R2, in the end, what I'm getting? Negative. So this is negative IR2. That is equal to 0. So all devices completed, I mean to say resistance completed, sources completed, and this is the complete loop analysis we consider while doing the KVL analysis. So V minus IR1 minus IR2 is equal to 0. So what I did in this case, I consider first the conventional current direction, name I. Then I consider the battery terminal, positive, negative. The same way I started to assign the signs to the resistances, positive, negative, positive, negative. While moving in a clockwise direction, third point, I consider the sign at the respective source in the end. This is positive, this is negative at R1 and also negative at R2, and I wrote that is equal to 0. This is simply KVL analysis. Now we will see the KCL analysis. Kirchhoff's current law. So what is this? This is nothing but the summation of current at the node or at the junction. At node or junction, that is equal to 0. So while calculating KVL voltage, we need to consider the loop, and while considering the KCL and while calculating the summation of current, we need to consider the node. So here we are considering the simple circuit. So with the help of circuit, we will see how it is. And this is what current. Say this is I1. This is R1. This is R2. And this is R3. So in this case, we have to consider the junction. Junction in the sense node. So here one branch, here other branch, and here one more branch. So this is nothing but, I'm taking a different color. This is nothing but node. This is nothing but the junction. So here I1 current is flowing through resistance, will come here towards the node, and incoming node will come here, will flow towards the R2 and R3. We have to decide the current directions accordingly. I1 current is flowing through R1, coming towards the node, and will flow through the R2 and R3. So I name this current I2 and this is I3. If I consider this is I1, which is equal to I. So how can we calculate? This current will flow through this resistance, will be coming towards the branch, that is nothing but I1, and will flow towards R2 and R3. So this is I2 and I3. So how to write the equation? I1 will be positive because it is coming towards the junction, and those currents are leaving from the junction. We have to take the negative, that is I2, and this is also going away from the junction, so minus I3, that is equal to 0. So what I did, those current coming towards the junction, that is positive, and those currents leaving from the junction going away from the junction, that is negative. So I1 minus I2 minus I3, that is nothing but the summation of the current at the junction or node. This is equal to 0. This is nothing but the KCL. So while doing analysis of any circuit, we have to remember these two laws. We will see in the next video. Thank you.